Go.
Hello.
Hello, Mr. Aaron, Mr. Ryan. How are you today? It's Friday today. It's Friday, okay? So do you still remember palindrome?
Yeah.
What's palindrome?
When the palindrome.
What's palindrome?
A palindrome is a palindrome. If you
Come on, give me an answer. What's the palindrome? Can you give me an
if
example?
you reverse it, it will be the same.
It will be the same. Okay, so can you give me an example?
Riska.
Race car, yeah. So for example, S if it's a palindrome, then what we can get is it's reverse, it's still the same. So how do you reverse it? This one, do you still remember? 2 double column minus 1, and that will be equals to S. That will be returning the true, okay? Yeah, does it make sense? Okay? So today, listen carefully, okay? Listen carefully. So today you're given a string, let's say A, B, C.
D, E,
No, that's
F,
it.
G.
A, B, C, maybe C. So how many unique?
Three.
How many unique? Three. Yeah.
Three.
So let's say there are T different unique letters, right? T unique letters. Remember, it's unique, okay? T equals 3, but length is 4 because there are 2 C, but there are three unique letters here.
Okay.
And how about I tell you that I want to make a palindrome that is size of K. Palindrome. Let I give you some size. But you can use the letters, the characters in here. Look.
As many times
As possible. Okay. So
as
look.
you want.
As many times as possible. For example, you can use A K times. It doesn't matter. It's a palindrome, right? So for example, if K equals 1, so what's the answer? How many palindromes of single size? Why is it 3?
Cause.
You can pick 3 is a good answer. Yes.
Ow.
So
Yeah.
so what's 3?
There's 3 unique numbers.
Yeah. So 3. Okay. 3.
Letters.
So that actually is T. Okay. Let's put T. Right? Yeah. K equals 2 equal how many? How many? K equals 2.
9.
How many?
No.
K equals 2. Okay, so this is two palindrome. Okay, so how many possibilities I
6.
can?
No, 3.
How many I can pick for the first one?
3.
3. Yeah. When I pick a 3, this one is just the middle, right? Yeah.
Yeah.
You pick one and you determine this one is fixed, right? Because if you pick A, this one must be A, right?
Yeah.
So it's T. It's again T.
Yeah.
How about K equals 3?
Maybe 9.
Why is 9? Can you tell me?
I think it's like.
Okay, 3. Okay, 3 letters.
T again.
Right, look. How many possibilities for the first one?
3.
3 T.
I guess so.
But if this T, this has to be the same, right?
Yeah.
So this middle one, there's an odd number in the middle. It means that I can put how many choices here? If it's
3.
3, yeah. You can pick,
T.
for example, you AA, that's 2, yeah? You can put A, B, C in the middle, right?
I think it's 9.
A, B, C in the middle. It's still a palindrome, right? So each one, you T times T, right?
9.
Okay. Well done. How about K equals 4?
Oh.
Can you tell me? 4 palindrome size string of K equals 4. Size 4. How many possibilities?
16.
16. Why is 16? Can you give me an example? Cause what?
8.
Cause what? Ryan, want to give answer? Why is 16? How
Cause
many possibilities of first one?
4. Yeah. And the last
T.
one. And
T.
the last one has to be the same as the first one. And the middle 2 have to be the same.
So yeah. So when you know there are T options for the first one,
Yeah.
you also the last letter is also fixed there.
Yeah.
And the second one is to the second to the last, right?
Yeah.
So how many possibilities here?
T.
T. Yeah. So it's T times T. Got it?
Yeah.
So does it make sense now? So what's the conclusion? Okay. I'm going to write this. Okay. Okay. Define count. Let's say count palindrome, yeah? And let's give a string and then give a k. Or what's missing?
Column.
Okay. Now what should we do? We need to count how many unique letters in the S, right?
Yeah.
How can we do it? What are we using?
Return T.
No. This S. So what? How many?
If K is 1, return.
Yeah, you can do this if k equals 2, if k equals 3, k can be unlimited. Are you going to write 1,000 or million times of if? Yeah, we're not going to do that. It's not possible, right? Are you sure? So, what kind of data structure are we using here to count the unique numbers in, remember the one in Python we start with the C, C, O. Can you read it after me?
N?
C-O-U, what's?
Counter.
Well done, yes, counter. So after counter, yeah, counter, you will give me a a notebook, yeah? Hash map, a notebook with the keys. What's the key? Key is the unique number, and the value is the number of terms that appear in a string, am I right? Yeah? Okay?
Yeah.
But the number of times we don't care here. We just want to know how many unique numbers. Or we can use the set, Eric. We can use the set. Look, let's say, look, Eric. T equals, yeah, remember this is the T, yeah, option, Eric.
Option.
Length, right?
Oh, if
Set. We use the set as.
A.
Does it make sense? Eric?
Yeah.
We're turning this string into S set. Set does not contain duplicate elements. So you only give me T. That will be unique. Okay, then how do we do this, Eric? Then look, we need to know if K and 1, or let's say K modulo 2, okay, it's the same, yeah? Equals 0 if it's the odd number. Alright? If it's the odd number, what should we return?
We just.
Else, what should we return? That's it. If it is the odd number,
square it.
square it. So yeah, how K is odd. This is even number.
Oh yeah.
Look, this is even number. So what's the answer? Return what? Return what? What's the even? T, yeah.
Square.
Square what? We want to know. Look, T times of K divided by 2, right?
Yeah.
Yeah, let's not square, right? Because you need to look. This is even numbers. How many is this? This is K, right? And how many is this? How many? Wait. This is K. How many is this?
T K divided by 2.
Yeah, and each one has T options. So it's T times K divided by 2 times, right? Alright? And how do you calculate this in Python? Remember? T, you can use the power function or double multiply, right? Alright? Yes. Alright, follow me.
Yeah.
Are you following me?
Yeah.
K divided by 2. Okay, and how about it's odd number? So what should we do? Odd number. Return what? Return what? Can you tell me?
You just square it, I think.
Return. Look, if it's another one, what should we do?
Oh, we just.
Times one more, right?
Yeah, times one more.
So it's return T
Times one more T.
K divided by 2. K divided by 2 is still this bit, yeah? And then times T, right? That's it, right? Yes? What's the term complexity?
O-N square. N. O-N. Cubic.
O-N, yeah?
Yeah.
Wait, let's see. What's this bit? Set.
Count.
We need to go through these the characters in S. So let's say, look, no. Look there, if there are N characters in the S, so this part is the O-N,
That's
okay?
my favorite one.
Okay, and how about this part? We want to calculate the power function. Remember, what's the complexity of this? Remember, how do we calculate 2 to the power? Let's say how do we calculate
Again?
2 to the power of 10? Do you multiply 2 10 times? this is on, right? But you can do it better, right? Remember?
Yeah.
How do we do this? 2 to the power of 10 equals 2 to the power of 5 times 2, right? Yeah?
Yeah.
Does it make sense now?
Yeah.
So you can square, or you can do this, square the base,
Is that
and
log
then
n?
yeah. Does it make sense? Yeah.
Log n.
Maybe this may be not obvious. Maybe look, 2 to the 128. The brute force way is to times 2, 128 times, right?
That's
Slow. Then you can do this 2 to the power of 2, square it, and that becomes 64, right? Look, I just need to, this is base. I just need to square the base, and then I can reduce the exponential, right? Half, yeah? And I can keep doing this, right? And 2 to the power of 2, and to the power of 2, 32, right? Yeah? Look, this is again half, right?
And half n.
Half. So let's log n, right? In this case, log k, right? Alright?
Yeah.
So O log k.
Oh, maybe
So-
it'll be O n log n? Log
No, I'm just saying this is O(n), this is O log k. So what's the time complexity?
O n log k?
Why you multiply? It's two different things, two different events. This cost A, this cost B. How much does it cost?
O n plus log k?
Yeah. Look, this is costing A, this is costing B. You add, how much together? Add it together. When do you want to multiply? Look, if this thing cost k times, and then for each k you need n times. Does it make sense?
Yeah.
So how much complexity is this one?
OK times n.
Yeah, do you understand? When to time, when to add. Yeah? If it's adding, it's separate. If it's multiplying, what does it mean? It means that one is inside another. Right? Am I right? Does it make sense?
Yeah.
Okay. So look, O(n) plus log k, which is bigger? I don't know. I don't know because kn. So it may be better we just do O(n) plus log k. Because we're not sure which one is bigger, right? Yeah? Or maybe you can do this O max n O or log k. So you pick the maximum one, okay? This is also okay, good, okay? Does it make sense? Yeah?
Yeah.
Can we erase this if? Erase this if.
Maybe.
Because look, because this is the same, yeah? The difference is times one more time, right? Yes?
Yeah.
Yeah.
And a hashtag.
Hashtag, that's okay. Hashtag is the common, okay? It's that for computer, for human. It's not, it won't change anything, okay? You know what's common? Common, yeah?
Yeah.
Yeah, common. It's for people to read, to understand. It doesn't have any impact on the logic, right? Okay. So look, so if k is odd number, so we need to times one more, right? So if k equals 3, well, we want to, if k equals 3, we want to times it, k divided by 2 plus 1 time. If k equals 2, odd even number, we want to do this, right? And 4, we want to do this, right? And 5, we want to do this. Right? Does it make sense? If it's odd number, we want to add one more time, right? Yeah? So we can introduce one more function called sphere. You know what's sphere? Sphere is short for ceiling. What's ceiling?
The top of the roof.
Yeah, exactly. Sphere. And then what's the opposite?
Floor.
Floor. Yeah, where's that floor?
The bottom.
But in Python, look, if 3 do this, this is already floor because it will give you 1, right? Right? So what's 3 divided by 2 in mathematics? If it's single divide, what's 3 divided by 2?
1 1/2.
1.5. Well done, 1.5, right? If you use 2 double, it gives you the floor, which is 1, right? Because it's not yet 2. It just erase this.
How do you do the top?
Top, yeah, sphere. So look, sphere, 3 divided by 2, that will give you 2. That will give you 2, okay? Does it make sense?
Yeah.
this is kind of original. 3 divided by 2 is 1.5. And in Python, you want to do the floor, which is I don't want the, I can erase this bit, yeah? The fraction is lower half. It's like 1.5 here. Floor, 1. Here, 2. Does it make sense?
Yeah.
So look, so we can just do this.
Oh, yeah?
T, yeah? How many kinds of T? Here, K divided by 2, single K, right? That's it. Yeah? Alright, look, does it make sense?
Yeah.
If K equals 3, 3 divided by 2, 1.5. Here will be 2.
2.
Right? Yeah. If K equals 4, 4 divided by 2 is 2. Here 2 is 2, right? Yeah? Here any integer part is, here 100 is 100. Here 99 is 99, right? Here 99.1 is what?
100.
Yeah. Floor 99.1 is what?
99.
Floor 99 is what?
99.
499 is 99. So any integer part, 1, 2, 3, 4, let here and here or floor is there, right?
Yeah.
Here, let's one more time. 8.123 here equals
9.
8.99999 floor.
8.
Yeah, well done, you got it. Okay, so look, K equals 4, 4 divided by 2, 2 here is 2. Yeah? T times 2, right? T squared, right?
Yeah.
Okay, that's it for today. So what you remember, yeah? Complexity, O n plus log K, right? Why is it log K? Because we want to calculate this. Power function A
Yeah.
K is O log K, okay? Yeah? Does it make sense?
Bye.
Does it make sense?
Yeah.
Okay, good job today. You want to say thank you or see you tomorrow?
See ya tomorrow. Yeah.
That's it. See you tomorrow.